Okay, today we're looking at trapezoids and kites. A trapezoid is, of course, a quadrilateral. It's a quadrilateral with one pair of parallel sides. For instance, if we're looking at this parallelogram or trapezoid, we're looking at those two sides being parallel. If a trapezoid is isosceles, then each pair of base angles is going to be congruent. So if we're looking at this trapezoid here, and we say that this is an isosceles trapezoid, that pair of base angles is congruent, and that pair of base angles is congruent. Of course, it's going to have one pair of parallel sides, and these segments will be congruent. If a trapezoid, way to prove a trapezoid is isosceles is if a trapezoid has one pair of congruent base angles, then the trapezoid is going to be isosceles. So a trapezoid is isosceles if and only if its diagonals are congruent. Similar to a rectangle square where the diagonals are congruent. So, next thing we're looking at is the trapezoid midsegment theorem. A trapezoid has a midsegment. The midsegment of a trapezoid is parallel. So the midsegment is this red dotted line. But it's parallel to the base sides of the trapezoid, the parallel sides, to each base, and its measure is half the sum of the two base lengths. So let's look at this example. That's really all we're looking at as far as we're talking about trapezoids. Let's look at what this says about. I'm going to zoom in on this picture and you can read. Well, I'll put it right about there. So it says here, if each side of the basket shown is an isosceles trapezoid, which means the diagonals are going to be congruent, the base angles are congruent. So it says on part 1, find the measure of MJK. Well, MJK is this angle right here. The angle they give us is JML, which is this angle, and it's 130 degrees. But you'll remember that these are basically two parallel lines with the transversal. So those two angles are going to be supplementary. So we can take 180, subtract 130, and get 50, which means that angle, MJK, is 50 degrees. Okay, so corresponding sides are supplementary when we're talking about the two base angles that are not congruent. Okay, continuing to look at this, but looking at part 2. Try and erase that as well as I can. It says that we're looking for MN. MN is this segment right here. Now it tells me that KN is 6.7, so that part is 6.7, and JL, the whole entire diagonal, is 10.3. Well, both diagonals are congruent, so both KM and JL are 10.3, but if I take 10.3 and subtract 6.7, that's going to give me what's left, which is MN. And when I do that, I get 3.6 inches. So MN is 3.6 inches. All right, now this question here, determine whether or not this is a Show that ABCD is a trapezoid and determine whether it is isosceles trapezoid. So we'll determine I would determine that it's a trapezoid by seeing if it has one pair of parallel sides. We know that these sides are not going to be parallel, right? BC and DA, because their slopes are different. One has a positive slope, the other has a negative slope. So let's check on CD and AB. So if we're looking at the slope of CD, we're going to subtract the y, so 4 minus 3 over 2 minus negative 2, which gives us 1 over 4. Now we're going to check the slope of AB. So we're going to say 1 minus negative 1 over 5 minus negative 3. That ends up giving me 2 over 8, which reduces 1/4. Both slopes are the same, so it's parallel. So we do have a trapezoid, one pair of parallel sides. Now, the other thing we need to check to see if it's isosceles is if the diagonals are congruent. Remember, if DB is congruent to CA, then this definitely is an isosceles trapezoid. So we have to do the distance formula for segment CD. I'm sorry, not CD, BD. So we're going to say 2 minus negative 3 squared plus 4 minus negative 1 squared. That gives us 5 squared plus 5 squared. 25 plus 25 is 50. So we get radical 50. When I do the other one, which would be AC, distance formula of AC, we have 5 minus negative 2 squared plus 1 minus 3 squared. And what I get from that is 7 squared plus 2 squared, or negative 2 squared. 49 plus 4 is 53, so we get radical 53 when we do the work. These two are not the same. The diagonals are not congruent. Therefore, it's not isosceles. So it is just a trapezoid, not isosceles. So we check to see if it's a trapezoid by comparing the side lengths, the slopes, and seeing if they had one pair of parallel sides. If they did, we check the diagonals to see if they were congruent. Okay, now here we have that mid-segment question. The mid-segment is when we take the two bases, base 1, base 2, so in this case we have 20, and we add them together, plus x. We take half of that, because half of that is equal to the mid-segment, which is 30. So now we solve for x. Multiply times 2, 20 plus x equals 60. Subtract 20, and x equals 40. Looking at a kite is a quadrilateral with two distinct pairs of adjacent sides, congruent sides. So that means these two are congruent and they're adjacent. Now they are also distinct from these two congruent. That means that we don't have four congruent sides. This is not going to be a rhombus. If a quadrilateral is a kite, then 1, diagonals are perpendicular. 2, it has exactly one pair of opposite angles congruent. And in this picture of the kite, those angles would be right here and right here, where the two non-congruent sides meet, the angle formed by that. So let's look at an example. It says that we have a kite, find the measure of x, y, z. X, y, z is this angle right here. Well, we know that there are two angles that are congruent, and in this case it's going to be x and z. So this angle is 121. So we have to find the missing angle. Remember, a quadrilateral, all the interior angles are going to add up to equal 360 degrees. So if we take 73 plus 121 plus 121 plus my unknown angle, y, it's going to equal 360 degrees. We end up with 315 plus angle y equals 360. Subtract 315 from both sides, and angle y is equal to 45 degrees, which is the angle we were looking for. Okay, we have a kite. Find NP. Tricky question. NP is this side right here. Notice that it's congruent to this side. We do know that 6 is the length of this segment and 8 is the length of this segment. What we find is we have a right triangle. It's a right triangle because the diagonals of a kite are perpendicular. And what ends up happening is we have to find that missing side. So that becomes a Pythagorean theorem question. 6 squared plus 8 squared is going to equal x squared. 36 plus 64 is 100. Find out what x is by taking the square root of both sides. X is 10, which means this side is 10, but it's congruent to this side, and that side is 10. So NP equals 10. Okay, on the one that's going to be probably tricky, the lengthy one, is going to be numbers 3 and 4. You're going to do exactly as we did on the trapezoid section, where we compared the slopes of the 4 sides and we compared the distance of the 2 diagonals to see what type of trapezoid it was. Alright, and that's it.